This is the normal distribution practice that goes with the Pear Deck assignment. So I'm going to walk through this so you can work on the problems on the Pear Deck, or you could actually just do it here. But if the Pear Deck is assigned as an assignment, you do want to go through it and make sure you hit submit so it updates in the gradebook. Okay, so suppose 40% of the area under the standard normal curve lies to the right of Z. Which of the following is true about Z? So if I were shading in the area where I'm doing 40%, you have to think, am I going to shade from the right or from the left? Well, it says to the right of Z. So I'm going to start over here and start shading, and I've shaded very little so far. And I want to keep shading until I've hit about 40%. So not quite halfway, right? I would be shading in this piece. I would be stopping before I hit 0. So one important thing, when we're doing a normal distribution with Z, Z is standardized score. So it's a model that is, give me a second. So you have, this is how we write normal distribution models, mean and standard deviation. So for Z, we use n of 0, 1. So the mean is 0, and how do we know that? Well, the center is 0, right? The center's right here, there's your mean, and how far apart are they? They're just 1 apart. So you can see it right there, there's the mean, and there's the standard deviation. All right, so for stopping there, it's positive, so the correct answer is A. All right, so we shape to the left until we get 40% right here. So this should be 40% of the area. Let me go ahead and add that note. 40% of the area. All right. Now suppose 79% of the curve lies to the right of the Z. So that means we're still starting from the right, but we want to go over halfway. In fact, we're doing most of the way. So I'm going to guess it's right around there. Again, you don't have to be exact. The main thing is that you know what your halfway point is. So that this is 79% of the area. Now we can actually find out exactly what that is. And in fact, I'll go ahead and do it for this one. Normal distributions. Oops, let me scooch this in a little bit so you can see it. So the mean is 0, and the standard deviation is 1. I'm on the stapplet, and I guess I want to bring this down a little bit so you can see it. Plot distribution, and I want to calculate a value because I know the area. I'm not trying to find the area. And what did we say? It was 79%. So you have, if you try to say, oh, I want to do 79%, remember we're working in decimals here, so it's 0.79. And you can see, oops, to the right. So it's at negative 0.8. So if you look at mine, I actually overshaded just a touch. But it's not a big deal because they were just asking, is the answer positive or negative? And we did answer, it is a negative Z-score. All right. Okay. Wise. I always hate it when those little tools pop up and they won't go away. All right. So 79% of your area is right there. Okay. And your Z is actually about there. Okay. Find Z such that 43.7 of the standard normal curve lies to the left of Z. So now we're actually trying to find a numerical value. So we're going to use the stapplet. And what did we say? 43.7, and it's on the left. So we go 0.437. Make sure we have left tail. And we can even show the labels on the plot. And you can see, notice how it says standard normal distribution. A lot of times if I have a different mean and something else, you'll see n in those numbers. But 0 and 1 are the standards, so they don't have to show those numbers. So we'll take this little picture right here, and you can see that Z is negative 0.1586. All right, and I'll put that back in here and probably size it accordingly. Come on. So if you set up the stapplet, you should be able to get that value right there. And so we said Z equals negative 0.1586. 1586. All right. Okay. Find Z such that 92% of the standard normal curve lies to the right of Z. So 92%, put it at 0.92. Whoops. We want to the right. Calculate values. And you can see it's all labeled. And let me get a snapshot. Since it's standard normal, it knows on the bottom it says values negative 1.4501. But here on the curve it says Z because it says, oh, you're using the standard normal, so you must be working in Z's. And we are. So let me put that up. Let me size it down a little bit. Probably still needs to come down. Huh, that'll work. And so we have Z equals negative 1.4051. So let's make a note that when you're doing these first on the stapplet, so there's the answer. On stapplet, let's make some stapplet notes. Make sure the drop down is on calculate value. All right. And then you can pretty much, then it's pretty straightforward. All right. So you want to make sure the drop down's on calculate value right there. And I'll take a little picture just to make sure. So operation is calculate value. So that's what you want. We'll put that here. Since I can stick some extra notes in here, right? And then it's pretty straightforward. This one, let me do this one, was 43.7 to the left. So 0.437. And you make sure you do left, calculate, and it gives you the graph. So I'll just show you. There's the left tail, and that's how it comes out, just in case you're like looking at this handout and you're like, what did she do? Well, that's what I did. All right. So that should give you, once you have these two main things done, you are in pretty good shape. So there's the operation. Calculate a value. All right. And there's your mean, and there's your standard deviation, and then there's the rest, and it gives you the answer right there. See that? Okay. So, and then this one is also calculate a value. So now we want between negative Z and Z. So the secret on this is 85%, so I'll put 85, is we want central area. And that's your answer right there. Just make sure you do central area and you're golden. And it gives two values. Now, on WebAssign here, you could give me different values and it's not that big a deal. WebAssign is looking for a particular number, so typically if it's on a quiz or something, I'll probably want the positive value. All right, we want the positive value. Why? Because they asked for Z. Find Z. They didn't ask you to find negative Z. They asked you to find Z. So let me go ahead and do a little capture on this drop down right here so that you can see. And you're probably going, wait, these numbers are the value. Yeah, it is. It's got an X there. And if you're doing standard normal, these numbers are going to match, period. They're the same. All right, next section. Now we have something other than Z-scores. We have basketball players, and the mean height is 78.3, and the standard deviation is 2. So we go ahead and we update our model, 78.3 and 2. And what do they want for the first part? Probability the player's height is less than 73.5 inches. So that's calculate an area, all right, and 2 less than, all right. 73.5, I believe it was. So here we have, let me go ahead and copy this calculate an area piece down here. Oops, I don't have the labeling. Let me label I can't go away. Label my plot so I have all my values there. So now we'll get it. So, and you notice now instead of it saying standardized normal, it says N78.32 because that's our model. And we're doing calculate a value. So, oops, I forgot to leave that in, but I'll just capture it here. So there's the area. Make sure drop down is on calculate an area. All right, because area and probability are those are the same idea on these curves. Okay, so the area is, or the probability is. Now, if you have percents, you might see this. Be prepared to give the decimal answer, not percent. All right. So a lot of times sometimes we'll ask for answers in percents, but most of the time we ask for answers in decimals. Okay, what is the probability that an NBA player's height is more than 81.5 inches? So we just go to the right of the value, put in 81.5, calculate the area, and boom, there it is. And we'll put it over here. Shrink that puppy down. So it's 0.0548. If you're looking at the Pear Deck, it might say 0.055. So on the Pear Deck, the answer, actually, let me go here. Yeah, this is the answer right here. This right here is your answer. Okay. On this one, the area is probability equals area equals 0.0548. All right. So it's not the 5.48%. It's, I'm sorry, 5.48%. It's that area. So in fact, I'm going to leave the answers in the decimal format. If you're getting percents and you're like, oh, I hate switching, do you know you can change it here? So what I did, I click on, let me scroll down and hit done. Just click on the suggest rounding percent proportion preferences, and you can switch to percentages or decimals right here. All right, so, and let's go back to the next question. What is the probability a player's height is between 73.5 and 81.5? So that would be between two values. And there you go, 0.937. So it's over 90% players. All right. I could have said also, what's the proportion? That would have worked. And let's go ahead and see. Yeah. There's the answer right there. And probability equals 0.937. All right. Then they say, what would the cutoff height of the shortest 15% of players be? So you know if they're on the shortest side, they're on the left here, right? Because these are the short players. These are the tall players. So shorter players on the left. Looking for a value. All right, not an area. So you got to switch it. Switch drop down. All right, so let's go to our drop down. We're going to switch it, and we wanted the shortest, what, 15%. So the shortest 15% is to the left. Oh, make sure, yeah, calculate, I already did. And then we said 15%, 0.15, and boom. All right, so make sure it's on the left side. And there you are, 76.227. Seems overly precise, but it'll better to be overly precise on these, on your web assigns, because it will do some rounding for you. If you're overly precise, it won't ding you, generally, almost never. But if you're overly rounding, which many of you are prone to do, then it will ding you for rounding too much. All right, so the height is 76.2271. All right, or about 76.2, depending on how you round it. Okay. So what would the cutoff height for the tallest players? So the tallest players are on the right. So in this top 10%, so we're going to go right tail 10%. Calculate value, and you can see that. And here we go. So the cutoff for the top 10% would be 80.86 inches. So value height equals 80.86 inches. So it's basically, let me make sure I highlight these. Maybe I should just highlight them with the highlighter. So there's the answer there. There's the answer there. Here's the answer here, there. Here's the answer up here, just in case you're wondering where the answers are on this graph. Oops, too much pink. Okay, and then finally, the low end of the middle 60% of players. So we're almost done. So we're going to do central. Change that to 0.6 or 0.60, however you feel. Calculate your value, and voila. Copy. Paste it here. Ooh, we can have a big one too, because I got extra space. I'll just use the big area right there. And so we want the lower area. So definitely use the lower cutoff value, which is 76.6168 or 76.62 inches, because I think I went 4 decimal places here. So the answer is this piece right there. Make sure you did central area. So that's it. Hopefully that was pretty straightforward for you. Again, if some of this didn't make sense, you are welcome to bug me with questions. It's very helpful if you ask a question about a specific problem, and then we can generalize after that.